Assalamu alaikum. Good afternoon. I, Rosina Akhtar, Assistant Professor, Department of Business Administration, welcome you all in today's live session on Smart PLS concept, theory, and application. This program has been organized by Department of Business Administration, Faculty of Business and Entrepreneurship. This is a live stream from Campus TV, so audiences can put their questions and remarks in the comment box. For today's talk, it's our pleasure to have Dr. Muhammad Mehdi Masood, a senior lecturer, Department of Development Studies, University of Malaya, Malaysia. And as a session reactor, we have Mr. Nurul Muhammad Zaid, Assistant Professor of Department of Business Administration, Daffodil International University. Gentlemen, welcome to the board. Smart PLS, as we know that partial least squares path modeling or partial least squares structural equation modeling, method of structural equation modeling, which allows estimating complex cause-effect relationship models with latent variables. And before we jump into the main session or main discussion, let me just get you a brief overview of today's speaker. Dr. Muhammad Mehdi Masood is currently a senior lecturer at the Department of Development Studies, Faculty of Economics and Administration, University of Malaya, Malaysia. He published a book by Pelgrave Maclean in 2019, book chapters, and over 50 scientific articles in internationally peer-reviewed journals in the field of sustainable development. Currently, he leads several research projects such as the Fundamental Research Grant Scheme, Long-Term Research Grant Scheme, and faculty projects. His research interests cover sustainable development, development economics, environmental impact assessment, ecotourism, climate change adaptation and mitigation, community development, means of livelihood, poverty, and social mobility. He has received several awards, such as the Academic Excellence Award based on most high impact publications, and the Bangladeshi Students Award from the University of Malaya, Malaysia. He is an associate editor of the Journal of Institutions and Economics and an editorial board member for Ecofeminism and Climate Change, an international journal of environment and sustainable development. So, ladies and gentlemen, please welcome Mr. Muhammad Mehdi Masood. Sir, floor is yours.
Thank you very much. Thanks for having me here. Assalamu alaikum and good afternoon to everyone. First and foremost, I'd like to thank the organizing committee who invited me to deliver this workshop. A special thanks goes to Rosina Akhtar, who communicated with me to make it happen. And I would also like to thank Dr. Nur Muhammad Zaid, Assistant Professor, Faculty of Business and Entrepreneurship, Daffodil International University. So without further ado, let's start our workshop. So can you share a slide, or I should go without slide? Okay, so before commencing our workshop, let me motivate you by saying the statement of Richard Stallman: sharing knowledge is the most fundamental act of friendship because it is a way you can give something without losing something. So today we are here to share our knowledge. We can strengthen our friendship by exchanging knowledge and learning from one another without losing anything. So let's get started our workshop. Can you move next, please? Today we are going to talk about PLS, partial least square structural equation modeling, concept, theory, and application. Can you move, please? Next. So let me start with a question. Why do we want to employ PLS SEM in our research paper? So basically, we have two types of SEM. One is variance-based structural equation modeling. Another one is covariance-based structural equation modeling. So PLS SEM is variance-based structural equation modeling. So what is variance actually? In statistics, variance measure variability from the average, from the mean, while covariance measures the joint variability of two random variables. That means covariance essentially measures the relationship, the variance between two variables. So please take note that we use a smart PLS software, okay? A smart PLS software for PLS structural equation modeling, whereas we use AMOS software for covariance-based structural equation modeling. Sometimes we are puzzled with these two terms and we say it imperfectly. So basically, AMOS and PLS SEM, or it is a smart PLS, is a statistical software. So AMOS stands for analysis of a moment structure, and it is also known as analysis of covariance or causal modeling software. So both of them are graphical visual program for variance-based and covariance-based structural equation modeling. So what we can do, we can use them, we can draw models graphically using its simple drawing tools. So actually, let me show you the difference between variance and covariance-based structural equation modeling graphically. Although example I cannot show you because I had the link here. So anyway, so just let me tell you that covariance, two variables will covariate, okay, with two-headed arrow for covariance-based structural equation modeling. However, for PLS SEM, two variables do not covariate each other, okay? That is the graphical difference between PLS SEM and structural SEM. That means covariance-based structural equation modeling. Then second beauty of using PLS structural equation modeling, we can model both formative and reflective measurement model for in PLS SEM. Whereas if we use AMOS or structural equation modeling, we can model only formative measurement model. So formative measurement model happens when the measured variables are considered to be cause of latent variables. So that is the formative. So let me give you an example. What is formative measurement model? For example, the price of a car. So the price of a car depends on few things. Depends on its age, depends on its condition, it depends on its size, it depends on its manufacturing year, and so on. So age, condition, and size can cause or form the price of a car. So that refers to formative measurement. On the other hand, a reflective measurement model happens when the indicators of a construct are considered to be caused by the construct. So that is the basic difference, that construct are considered to be caused by that construct. Okay, so let me give you an example. Let's say there is a construct, is called store image. Okay, so in order to measure a store image, it can be reflected by superior products, by economy product, by reliable product. So by these three products, it can be reflected a store image. So it is considered as a reflective measurement model. So this is the basic difference between formative and reflective model. So if we use PLS SEM, we can use both. But if we use a structural equation, covariance-based structural equation modeling, we can use only formative measurement model. Third, PLS SEM is an exploratory research. Okay, whereas covariance-based structural equation modeling is confirmatory research. So exploratory research basically investigates a problem that has not been studied, that has not been thoroughly investigated in the past. So basically, we employ PLS SEM for exploratory research. And confirmatory research, we just confirm a established theory. The next one, if we use PLS SEM, it is suitable for extension of a established theory. For example, let me give you an example. We frequently use the very popular theory is theory of planned behavior. Okay, so you can use this theory with some extension. That means it has 6 elements, 6 or 5. So you can add few variables with this established theory. So this is considered extended theory of planned behavior. So if you do this kind of research, then you should use PLS SEM. And PLS SEM is suitable for extensive research. Okay. Whereas if you use covariance-based structural equation modeling, you can test a theory which is already established. As I mentioned earlier, theory of planned behavior, without adding or extending any variable. Okay, just you can test this theory, you can confirm this theory, or you can compare this theory with an alternative theory. If you do this kind of research just to test a theory, just to confirm a theory, just to compare a theory with an alternative theory, then go for covariance-based structural equation modeling. But if you want to use PLS, that means variance-based PLS structural equation modeling, then go for extension of theory. You can go for extension of theories. Another beauty of using PLS SEM, it is appropriate for a small and large sample size. But for covariance-based structural equation modeling, not appropriate for a small sample size. So basically, what do we understand by saying a small or large sample size, there is a school of thoughts, but I'm not going to discuss that issues. But the general rule of thumb is we consider 30 to 200 is a small sample size. And if you go 200 to 800, we consider large sample size. The next thing is that if we use PLS, structural equation modeling, you can use non-normally distributed data. Okay, data should not to be normally distributed. But if we use covariance-based structural equation modeling, data should be normally distributed. Okay, but this is the beauty of using PLS SEM. You don't need to you don't need to be concerned with the normally distributed data. Okay. Then the next thing is model fit indices are not major concern in PLS SEM. Okay, because PLS SEM is not the main purpose of PLS SEM is to see the relationship among the variables. It's not to see the fit indices or fit model fitness or model fit indices, okay, matrices. But if you use covariance-based structural equation modeling, the model fitness is a major concern. You have to look at RMC, you have to calculate degree of freedom, chi-square, you have to see CFI, NFI, GFI, many more. Okay, so you have to be concerned about the model fitness. But if you use PLS SEM, you don't have to be concerned too much about, but you can see the fitness. Then the next beauty of using PLS SEM is you can use moderating variable, can be categorical, can be ordinal, can be interval, as well as ratio scale. But for covariance-based structural equation modeling, it is preferably categorical variable. Then last but not least, PLS SEM or variance-based SEM is user-friendly. And of course, it has colorful graphical presentation. Similarly, covariance-based structural equation modeling is user-friendly and has a colorful graphical presentation, but it is not as friendly as a smart PLS. So because of these basic reasons, I prefer to use variance-based structural equation modeling over covariance-based structural equation modeling. So can we move to, actually I wanted to show another example of the measurement model, but once I couldn't open this link, just to tell me, let me tell you that basically the reflective and formative measurement model refers to the first order model, okay? But we can do second order, third order, okay? So if we go for second order model or third order model, we can have 4 types of measurement models, okay? So for example, type 1, we can have reflective, the first order model is reflective, second order also reflective as well. And second type of measurement model can be reflective in first order and formative in second order. Then third type of measurement model can be formative in first order and formative in second order as well. Then the last measurement model is formative and reflective. That means first order it can be formative, and second order it can be reflective. So this is, we have 4 types of measurement model. If you go for second order, third order, or fourth order, it can be combination of reflective and formative measurement model. So in a model, you can have both formative and reflective measurement model. Okay, can we move next slide, please? Okay, so let me ask you the question, okay? What motivates you to attend this workshop? Since we can't listen to the audience, okay, so audience can write their comments, okay, in the comment box. Okay, anyway, of course, we know we are here to know how to publish journal articles employing PLS SEM. So in order to publish journal articles or research paper, or in order to write thesis or dissertation, master's or PhD dissertation or thesis, how to use this smart PLS, okay? So we are here to know how to publish journal articles using PLS SEM. So can you move the next slide, please? So in order to write a research paper, in order to write a thesis or dissertation, okay, using PLS SEM, we can follow this basic structure of the analysis, okay? So these are the basic components should contain your research articles, your research paper, your dissertation, or your PhD thesis, okay? So the basic components of analysis, okay? Let me remind you that I'm not going to talk about how to write an abstract, how to write an introduction, how to review literature critically. I'm not going to talk about methodology. Today, I'm going to talk about only how to analyze, okay? How to analyze using PLS SEM, and what are the components, elements should be contained in your research paper. If you want to write a paper, research paper, if you want to publish a research articles, what are the things, what are the components, elements should contain in your paper? So basically, I have divided this structure of analysis into 3 parts, okay, into 3 parts. You can find it anywhere. Is my okay, my work, okay? So I have divided into 3 parts to make you understand, okay? Part 1, basically we do measurement model, okay? We develop or we test measurement model, okay? So measurement model can be reflective or can be formative, or it can be mixed, okay? Both reflective and formative if you go for second order, okay? So let's say the first part in your research paper or in your thesis, what are the things, what are the components, elements should be contained? In this part, we will look into 2 things. One is called convergent validity, okay? And second thing is discriminant validity, okay? So how we check convergent validity? We refer to indicators loading. Indicator loadings. It is also called outer loadings. It is also called item loadings. Okay, so don't be puzzled. Okay, it is the same thing. Okay, some might say indicator loadings, some might say outer loadings, some might say item loadings. Okay, so this is one thing in order to see convergent validity. So what is convergent validity? We'll talk about later, okay? Just let me introduce first, okay? Then also we we will refer to ABE, average variance extracted. Okay, we'll look at it. Then we look at composite reliability. Oh, sorry, before is Cronbach alpha. I think all of you are familiar with Cronbach alpha. So we'll look at Cronbach alpha for reliability check. Then also we'll look at composite reliability. CR represents composite reliability. There is another reliability is called rho underscore A, okay? That is also reliability. So what is the difference between composite reliability and rho is underscore A? It is, what is the difference between these two? Actually, it's the same thing. But composite reliability uses a standardized value, okay? And rho A uses unstandardized value to calculate the reliability, okay? So that is the basic difference, okay? And there is another one, I think you heard the name, is called McDonald's Omega Reliability. Have you heard the name of this? McDonald's Omega Reliability. It is new to me, okay? So there is many ways to check the reliability or convergent validity. Okay, so this is the first component, we look at it. Then the second component is discriminant validity, okay? So how we'll ensure that our model has discriminant validity, looking at cross-loading. This is one criteria. Then second criteria, we look at HTMT. My student used to say HT Imam. Okay, it's not HT Imam, it's HTMT. Okay. Then another criteria is funnel and Lacquer criterion. Okay. So basically, we look at these three criterion to confirm discriminant validity, that our model has discriminant validity. Okay, so this is the first part. Okay, I think it will be more clear when I will show you the practical example. Okay, okay, then this first part done. Okay, so these are the things you should contain in your research paper, in your research articles, or your thesis or dissertation. Okay. Then the second part is called assessment of a structural model. Okay. That means we want to see, or we want to test our hypothesized model. Okay, we want to test our hypothesis. Okay, before starting our research or analysis, of course, we have developed research hypothesis. Am I right? So now we want to test. So before testing hypothesis, we have to check BIF, variance inflator factors, in order to avoid multicollinearity. Okay, we have to check is there two variables highly correlated or not. Okay, so we have to check BIF before testing our hypothesis. Okay, then we'll look at path coefficient. I think it is also called beta coefficient. Okay, I think all of you are familiar with it. Then also we look at standard error. Then we'll look at T statistics as well as P value. Okay, whether there is a significant relationship between X and Y or not. Okay. Then also we look at R square. Then we look at F square, effect size, and also we look at predictive relevance, which is Q square. Okay. So what is R square? What is F square, Q square? I'll tell you later, because this is just I'm showing the structure of the analysis. Okay. So this is the second part. Finish. Third part. If you want to test the mediation effect, if you want to test mediation effect or moderation effect, or if you want to see the multi-group, if you want to do multi-group analysis, okay, or if you can see importance performance map analysis. Okay, so if you want to see these things, mediation effect, moderation effect, multi-group analysis, IPMA, importance performance map analysis. If you want to do this kind of analysis, so you have to have this part 3, okay? So let me give you an example how to remember these things. Let's say you are a medical doctor, okay? You are a medical doctor, okay? So one patient came to you. He requires operation, okay? He requires operation. So before sending him to the operation theater, what you should do as a doctor? You should test, diagnosis test, am I right? His pulse, sugar level, okay, anesthesia test, and so on, okay? Then if you see everything is okay, then you send your patient to the operation theater. Similarly, the first part is our diagnosis test, okay? Diagnosis test. You need to check your items, you need to check your construct, whether it has convergent validity, it has discriminant validity or not. So that means your patient is ready for operation or not, you need to check. So this is the first part, okay? You need to do some diagnosis test, okay, before sending to the operation theater. Then the second part, you send patient to the operation theater to have operation, okay? So that is our hypothesis testing, okay? So we want to test our model, our hypothesis, okay? That is our second part. So we can have two types of operation. One is minor operation, another one can be major operation, critical operation, am I right? We can have two types of patient, okay, operation. So if you have the minor operation, the patient requires minor operation, then you go for second part, okay, assessment of a structural model. That means you just do the minor operation or you just test your hypothesis, whether there is a relationship between variable X and Y. You test it, okay? So you can stop here, okay? Patient will go back, okay? But let's say your patient requires critical operation, okay? Then you have to do one more operation, okay? And it is advanced level, okay? So then you can go to the third part, okay? That is, we consider mediation and moderation effect or multi-group analysis, IPMA, okay, and so on, okay? So that is the basic idea given to you is an example, okay? To this is the to remember this, okay? The structure of this analysis, okay? You can find it in the book, okay? Okay, can you move next slide, please? Is there any question, please? Actually, I'm not feel okay to say next, and also I cannot show the example, okay? Anyway, sorry for the interruption. I hope you will understand I'm not habituated with using this. Okay, anyway. Okay, next. Okay, now I'll go a little bit in depth, okay? Part 1, as we mentioned, remember, please remember the structure, okay? So now we'll go in details, okay? So let's say the first part, still we are in first part, but I'll go in details, okay? What is the first part? Evaluation of reflective measurement model, okay? Why I mentioned reflective, why I didn't put formative? Because I want to show you an example which uses reflective measurement model, okay? That's why I want to focus only reflective measurement model, okay? So as we mentioned in the structure that you should check convergent validity, okay? So what is convergent validity? Basically, convergent validity refers to how closely the new scale is related to other variables and other measures of the same construct, okay? So basically, the construct should not be correlated with related variables, not with dissimilar unrelated ones, okay? And we want to see the internal consistency of the items as well as internal consistency of the construct. Okay. So we look how many things? 3 things. Indicator loadings, as I mentioned earlier. You can say also outer loading. For PLS SEM, normally we use outer loadings. Okay. Okay. So what is the threshold value or cutoff value for outer loadings? All the item loadings should be equal or greater than 0.70 according to here. Okay. So this is the rule of thumb. Okay. Threshold value, recommended value, cutoff value. Okay. The same thing. Okay. So once you will run, okay, you want to see indicator loadings or outer loadings, your loadings should be equal or greater than 0.70. Okay. But there is a different opinions. Okay. If you develop new items, okay, then it can be 0.50, 0.40, 0.60. Okay. Different opinions. Okay. So but the most popular, okay, is this one. Okay. Established one, it should be 0.70. Then you will look at average variance extracted. Average variance extracted is a measure of the amount of variance. Okay. The measure amount of variance. Okay. That is captured by a construct in relation to the amount of variance due to measurement error. Okay, due to measurement error. That is the definition of average variance extracted. Okay, so what is the rule of thumb? The value should be AVE should be equal or greater than 0.50. Okay, 0.50. Okay, the reference is given there, so you may refer to this. Okay. Then the Cronbach alpha. Yeah, I think all of you know that in order to see the internal consistency among the items or among the constructs, okay, we use Cronbach alpha, composite reliability, and rho A, and also I mentioned another one, McDonald's omega reliability. Okay, so all of them just have same rule of thumb. The reliability value should be equal or greater than 0.70. Okay, so these are the things in order to test the convergent validity. You need to refer to these 3 things. Okay, 3 or 4. Okay, then let's you want to see discriminant validity. Okay, so in order to look at the discriminant validity, so you should look at Fornell-Lecker criterion. Okay, so basically it is a square root of AVE, average variance extracted, is larger than the correlation of diagonal. I'll show you the example, then it will be more clear. Okay, now I cannot show you the example here. Okay, then also we look at the cross loading. Okay, so cross loading, all indicators load high on its own construct but low on the other construct. Okay, for its own construct it should be higher, the loading, compared to other construct. Okay, that is cross loading. I'll show you the table. Okay, then also we can look for another criterion is HTMT. Okay, so HTMT value should be less than or equal 0.90. Okay, so if you want to use this on 0.90, you can refer to gold and others. But if you use this threshold value 0.85, then you can refer to CLAM. Okay. Then also we can look at the confidence interval. So confidence interval does not show a value of 1 according to Henseler and others. Okay. So these are the things or components we should look at to confirm that our model has discriminant validity. Okay. So two things. In first part, we look into two things. One is convergent validity. Second one is discriminant validity. Convergent validity, we look at outer loadings, average variance extracted, Cronbach alpha, composite reliability, rho. And for discriminant validity, we look at 3 or 4 criterion: Fonen and Lecker criterion, cross-loading, HTMT criterion, and confidence interval. Okay, so this is the first part. And also I mentioned the threshold value. Okay. Okay, can we move next? Okay, our second part. Second part is assessment structural model. Okay, as I mentioned, that second part, before testing our hypothesis, we should look at BIF. Okay, variance, inflator, factors. Okay, so BIF is a measure of the amount of multicollinearity. Okay, in a set of multiple regression variables. So in order to avoid multicollinearity issue, we have to check BIF value. So BIF value should be below 5 according to here, and according to Diamantopoulos, it should be 3.35. Sorry, 3.3. Okay, below 3.3. So let's say if you find 5 or below 5, then you can refer here. But if your BIF is below 3 or equal 3.3, then you can refer to this reference. Okay. Then the next things in assessment structural model, we'll look at the relationship. Okay, because we test hypothesis. Okay. So we check, we see the relationship between 2 or more variables. Okay, 2 or more variables. Okay, so how we look at the relationship? Referring to path coefficient, the beta coefficient. Then also we look at standard error, T statistics, and P value. Okay, so basically, if you find T value or T statistics is greater than 2 point, okay, you could say that there is a significant relationship. But is positive or negative, you have to look at the sign of the coefficient. Okay, then assessing the level of R square. Okay, also we need to look at the R square. Okay, so basically the R square statistics explain the variance in the endogenous variables, the dependent variables explained by the exogenous variables. Okay, exogenous is independent variables. Okay, sometimes we say dependent variables, it is also called outcome variables, or it is also called endogenous variables. And exogenous variables, we say what is called the independent variables. Okay, so simply it means that how much change in the dependent variable can be accounted by one or more independent variables to generate R square. Okay, so the R square value we need to see, but there is a level. Okay, according to here. Okay, if you find that let's say your R square is 0.25, that means 25%. Okay, change explain in dependent variables explained by independent variables. So you could say this is the weak. Okay, weak. Then if you find the 50% change, then you could say moderate level. Okay, then if you find 0.75, it's 75%. Okay, or above, then you could say the substantial level. Okay, so also you can explain the R square this way. Okay, then also we need to look at what is called the effect size. Okay, effect size. Okay, it is called F square. Okay, so basically the F square is the effect or influenced by a number of different variables. Okay, let's say we generate the R square. So there is 3 or 4 or 5 independent variables. Okay, so it has effect or influence to generate R square. Okay, so that the change in R square. So if we remove one variable, let's say we have 3 independent variables. So if we remove one variable. So what is the effect of that specific variable? So we need to see the effect size. So in order to see this effect size, we need to look at f square. So there is also label, okay? What is a small effect or medium effect or large effect? If you look at, if you see, if you find 0.02, that means you have a small effect. If you find 0.15, that means it has medium effect. If you find that it has 0.35, that means it has large effect, okay, in terms of effect size, okay. Then the one more thing we look at predictive relevance is the Q square, okay. So Q square is a criterion to evaluate how will the omitted data are estimated by the model, okay. So calculation of if square should be greater than 0, okay. The model has predictive relevance, okay, according to Funnel and Cha, okay. So this is the reference, okay. So in part 2, in order to assess a structural model or in order to test hypothesis model, we need to look at, first we need to look at variance inflator factors in order to avoid multicollinearity. Then we need to see the relationship, okay, between x and y, looking at path coefficient, standard error, t statistics, and p value, okay. Then we need to assess, to see the, also we need to calculate the r square, okay, to see the change explained by the independent variables, okay. Then also we need to see the effect size as well as predictive relevance. So these are the basic components we need to assess for part 2, okay, in order to see, in order to test our hypothesis model, okay. Can we move to the next? Part 3, please. Okay. So this is part 3, okay. If you want to see the mediation effect, okay, mediation effect, okay, then you can go for mediating analysis, okay. So let's look at this model with mediating factor C, okay. So first, let's say we find a significant direct relationship between A and B, okay. If we look at the direct relationship, let's say the first we find insignificant relationship between A and B, but significant indirect relationship, okay. So this is considered, that means the C mediates relationship between A and B. So we could say that there is a full mediation, okay. So there is no significant direct relationship, but there is an indirect significant relationship. That means the mediator C mediates the relationship between A and B. So we could say there is a full mediation, okay. So there is a full mediation. Then second, we can have 3 types, okay, mediation, okay. The one is full mediation, second one is the partial mediation, okay. Let's say if we find direct relationship between A and B as well as indirect relationship, okay, so it could be considered as partial mediation effect, okay. That means we can have what is called the direct significant relationship as well as indirect significant relationship. So we could say here is a partial mediation effect. And the third one, if we don't find any relationship, whether direct or indirect, so there is no mediation effect, okay. So we have full mediation effect, we can analyze full mediation, we can analyze partial mediation, or there is no mediation effect, okay. If you want to see the mediation effect of any variable, okay. Okay, then we can go to the next one, the moderating analysis, please. Okay. So moderating analysis if you want to see the moderating effects, okay, let's say we have two variables, x and y. In x, independent variable, dependent variable is y, okay. So we see the relationship between x and y, but we want to strengthen this relationship, adding another interaction term, okay, or moderating variable, okay. So we can add the moderating variable, okay. So because we want to see the relationship, we want to amplify the relationship between x and y. So we do moderating effects. We analyze moderating effects, okay. Okay, can we move the next one? Okay, then the last but not least, okay, we can do multi-group analysis, okay. So we can have two groups, okay, lower income groups, higher income groups. Is given an example, but you can have two groups. Let's two or more than, okay, is not necessary you have to be two, okay. Let's say the male and female, two groups, okay. Then what is called the education level, okay, the primary, higher secondary, university, postgraduate, okay. So you can have many groups, multiple groups, okay. So you want to see the difference among the groups. Let's say you are doing research about environmental awareness. So you have two types of respondents, male and female. So whose group are more aware about environmental issues? You want to see the difference. Is there any significant difference between two groups or not? Okay. So this is the multi-group analysis. And then we have the importance performance map analysis. Okay. Let's say you have few independent variables. So which variables is more important, okay, in order to make the policy, okay, in order to recommend the appropriate policy or strategies, okay. So you can do important performance map analysis, okay. So then can we move next? How many minutes we have?
Sir, we do not have much time, so can
Really?
you finish it by 4:10?
For okay, for 10. Okay, another 10 minutes. Okay. So basically, actually, is the basic idea of structure. Sorry, PLS structural equation modeling. So let me show you one paper. Okay, I have. Can you, Rosina Akhtar? Can you open my article? I send an article to your email.
Okay, let me see, sir.
Can you share that article?
I believe Arif has to stop his presentation, then I can share. Is it visible, sir?
Yes. Yeah, yeah. So actually, due to time constraint, we cannot proceed hands-on approach. Okay. So anyway, we may organize one more session. Okay, for hands-on if you want. Okay. So let me share one of our published papers, which employed PLS structural equation modeling. So I hope it will give you some ideas, okay, on how to write a research articles using PLS SEM. Okay, so you can look at this the topic. Okay, this is the topic title. Okay, consumers environmental ethics, willingness and green consumerism between lower and higher income groups. Okay, so the objectives of this article is actually it's too small. I cannot see. Okay, can you make it bigger, please?
Is it visible now? But I believe it's got broken. So should I read the abstract for you, sir?
Yeah, you can go to the previous version.
Yes.
Okay, so this study analyzes the impact of consumers' environmental ethics, green consumerism, moral obligation, green attitudes, and consumers' willingness to consume green products. Okay, and actual green consumerism with the mediating role of willingness to consume green products. Okay, this is the main objectives of this article. Okay, and we use PLS SEM. Okay, so can you move next to the? I want to show you the first part. Okay, how to write the first part because we have discussed the structure of the analysis. So you can see the practical one whether I follow that one or not. Okay, so you may grow your confidence looking at this article. It is already published at its Q1 journal. Okay, so you can go to the next table 2. Okay, if I'm not mistaken, go to the table 2. Okay. Okay, wait, please. Okay, this is our theoretical framework. Okay, so this model has four independent variables, one mediator, and another one is the dependent variable. And also we analyze the multi-group analysis between two groups, okay, lower income groups and higher income groups. Okay, can you move next? Go to the table 2, please. Oh, please, table 2, please. This is one. Okay. Okay, this is it. Okay. So as we mentioned earlier that part 1, okay, the measurement model. Okay. So we mentioned in order to see the convergent validity, we have to calculate outer loadings. Okay, outer loadings of the measurement model. Okay. So this is the table. Okay, and this is the outer loadings. Okay. So we need to look at these loadings. Okay, whether it meets or exceeds the cutoff value. What is the cutoff value? It's 0.70. Okay, so the wall loadings should be equal or greater than 0.70. But can you see there is one item loadings is less than 0.70. Item 10. Okay, item 10. Okay, is 0.6 something. Okay,
Yes, sir.
so yeah.
0.684.
Yeah, so what should we do with this item? Basically, based on this table, we are going to calculate the composite reliability as well as average variance extraction. Okay, so this loading is not going to affect the composite reliability as well as ABE. Okay, so that's why we should not, we don't need to drop this item. Okay, we can keep it. Okay, okay, go to the next table, table 3, please. Okay, the table 3 we presented construct reliability and validity. You can see Cronbach alpha value. Okay, all of them is greater than 0.70. Then also we have provided row A value, reliability value, same. Okay, all of them are above 0.70. Then also we have provided composite reliability. Okay, all of them exceed the cutoff value. Then average variance extracted. You look at the value, all of them exceeds cutoff value. Okay, so this is our table 3. So we have seen the outer loading. Then we look at construct reliability and validity. Okay, can you move to the next one, the table 4? I'm rushing because due to time constraint. Okay. Okay, then table 4. You see the discriminant validity. The first two tables refers to convergent validity. Okay. Then table 4, 5, 6 refers to discriminant validity. Okay. So this is based on Cornell-Laker criteria. Okay. So you can see the diagonal. Okay. Diagonals exhibit the square root of AVE, average variance extracted. If you see the diagonal, okay, diagonal is the exhibit the square root of ABE, and off diagonal portrays the correlation. Okay, correlation. So, what is the Cornell-Laker criterion? The cutoff value, it should be below 0. What is the cutoff value? I forgot. It's 0.90 maybe. Okay. Okay, you can see the cutoff value. Okay, so all of them meets the criteria. Okay, meets the criteria. Okay, then the next table, table five, please. Okay, this is the cross loading. Okay, you can see the cross loading. Okay, so you see its own construct. Consider the higher value. Okay, compared to the other construct. Okay, so this is the cross loading. Another criterion of discriminant validity. Okay, then table six. Okay, HTMT. Okay, you can see the correlation. Okay, among the variables. Okay, so all of them below the cutoff value. What is the threshold value is 0.90. Okay. Okay, so this is our second part, first part. Okay, we completed first part. Okay, can you move to the second part, please? Go to the. This is the model. Okay, the graphical presentation. Okay, you can look at this hypothesis model. Okay, okay. Then basically we look at the table 7. Okay, for the assessment 2. Okay, assessment of structural model. Okay, we look at path coefficient. Okay, the standard error, t value, then r square, f square, q square, and also we can write the decision. Okay, so this is our second part. Okay, then can we move to the third part? Is the table 8. Okay, it reflects the hypothesis testing of the mediation. Okay, so we also look at the coefficient, standard error, t value, p value. Okay, and also we look at the confidence interval. Okay, so this is the last part. Okay, as I mentioned, and also I think there is a multi-group. Okay, 4.6. Okay, the multi-group analysis, the last part. Okay. So basically, this paper consists of 3 parts. Okay, we have divided into 3 parts. The first part is the measurement model. Second part is the structural model, and third part is the mediation. You can use mediation or moderation or multi-group analysis and so on, or you can use all of them. Okay, you can see the mediation effect. You can see moderating effect. You can see multi-group. You can do multi-group analysis. Okay, it's up to you. Okay, so this is the basic structure of writing a research paper using PLS SEM. Okay, so I think I'm done. But if you have any question, please proceed. Welcome.
Thank you so much, sir, for your insightful discussion. I believe it has been beneficial to our respected faculty members, to prospective researchers, students, and um, everyone over here. And I have seen a lot of appreciation has come from audiences as well. So, right at this moment, um, sir, you have talked about um, mm, a formative measurement model, basically, and there is a question. Sometimes we feel that how to test validity for formative measurement model. This is a question from my end, I would say, and then I will move to the session reactor. Sir, over to you.
As we mentioned earlier, that we check convergent and discriminant validity for reflective measurement model. However, we need to check also the validity of the formative measurement model. So in this case, we don't refer to the convergent and discriminant validity. Basically, we check nomological validity, and also it is called the mimic redundancy analysis. Okay, so let me say what is nomological validity. Basically, nomological validity refers to the degree to which prediction in a formal theoretical network, okay, that continuing a construct of interest are confirmed. Okay, so that is the nomological validity. As I mentioned, the mimic or redundancy analysis, this refers to the principal component analysis. Okay, so the multiple indicator, multiple causes, okay, model, which enables uh, us to combine indicators, okay, tapping into the pleasant experience into one latent construct, okay. So those indicators of unpleasant experiences into a second one. Okay? So this is the redundancy, also called the principal components analysis of instrumental variables. Okay, so this is the way we check the formative measurement model. It's not like at the reflective measurement model. Basically, the reflective measurement model we test using looking at the conversion and discriminant validity.
Thank you so much, sir, for your wonderful sharing. Moving on to the session reactor, Mr. Nurul Muhammad Zayed, Assistant Professor, Department of Business Administration. Sir, floor is yours. I would like to ask you overall the idea of the session and if you want to complement anything.
Thank you very much for giving me the opportunity. First of all, I would like to thank Dr. Mehdi for giving us such an wonderful idea to make our research easier. Now, I would like to say, by complementing that, the research, we always say that research is for life. And PLS is for making the research easier, and PLS for research. Now, I would like to mention just a few things. From this session, we can see that this PLS is helpful for the exploratory research. And nowadays, we are concerned about the contemporary issues, capstone projects, and action research. Now, PLS would definitely help to make this action research, contemporary research, and these capstone projects very easier. How? As you can see, it will help to diagnose the data. It will help to make the data relevant. It will help to test the stationary of data. Not only it will help to screen the data, but it will also help to test the stationary of data. And half of the job will be done after testing the stationary of the data. Then after diagnosing the data, you will be able to know that the model you will use here, whether it is good fit for the research or not, by testing the collinearity, multicollinearity, serial correlation, heteroscedasticity. So these are the huge advantages of PLS. Now, definitely this session will help the existing researchers, the potential researchers, and side by side, this will also help for the potential students or graduates who will wish to become a researcher. And of course, the exploratory research will be easier if we can understand PLS and if we can apply this PLS accordingly. As you can see, our guest emphasized on the methodology and analysis, especially the analysis. Now, to conduct a research analysis smoothly, we need a good methodology. And we must have a consistency among objectives, methodology, and analysis. Then we can find robust outcome, which can be used as the outcome of action research. And this will make our life easier to run a model, to run a fittest model and come out with the more robust outcome. So thank you very much. Thank you for such a wonderful session. Thank you.
Thank you, sir, for your thought-provoking words. So, with this note, I would like to pay my heartfelt thanks to the honorable speaker, honorable session reactor, and all the people over here who have been connected to this live stream. And I'd like to wrap up the session with this note. And thank you so much, everyone, for your patient hearing. Thank you very much. Assalamu alaikum.